Let's have a look at the formula for resistance. Resistance opposes flow of current. Now this equation comes from Ohm's law. In this equation, resistance is designated with letter R, and it's expressed in ohms. Letter V is used for voltage. The unit for voltage is volts. Letter I is used for current. The unit for current is amps. Voltage V is voltage across the resistor, while current I is the current that flows through the resistor. In this formula, resistance is directly proportional to voltage. That means that the larger the voltage, the larger the resistance. Also, resistance is inversely proportional to current. So, the larger the current, the smaller the resistance. Resistance can be a property of a piece of wire or a conductor, an element in the circuit, for example a resistor, or a whole circuit or a network of elements. Sometimes we will use expression input resistance or output resistance of a circuit. Here is one example of application of this formula. Calculate resistance of resistor R1 if the following is known. We know source voltage Vs, 10 volts. We know resistor R2 voltage V2, 6 volts. And we know circuit current I, which is 1 milliamp. In order to find the resistance, we need to apply the formula R1 equals V1 over I. However, V1 is not given, so we need to calculate voltage across the resistor R1 first. If we apply KVL or Kirchhoff's voltage law for this loop, we can write the following voltage equation. V1 equals Vs minus V2. Thus V1 is 10 minus 6, which is 4 volts. Now we have everything we need to calculate the resistance R1. So R1 is V1 over I, which is 4 volts divided by 1 milliamp, which gives us 4 kilo ohms. Thus the resistance of resistor R1 is 4 kilo ohms. Even though this formula for calculating resistance is very simple, students sometimes make mistakes. Here we have an example of a series circuit. In a series circuit, all elements are connected in series. Remember, elements that are connected in series always have the same current. So in order to calculate resistance R1, we need to divide voltage V1 with current I. The mistake is to divide voltage Vs with the current I. Similarly, the resistance R2 is V2 divided by I, but not Vs divided by I. Thus remember, voltage in the formula must be voltage across the resistor, not just any voltage in the circuit. And because current is same for all the elements connected in series, doesn't mean that their voltages are same. Here is similar but opposite example where students also tend to make mistakes. This particular circuit is a parallel connection of two resistors. Remember, elements that are connected in parallel always have the same voltage. That doesn't mean that they have same currents, so we need to use corresponding current when we calculate the resistance. Thus the resistance R1 is Vs divided by I1, but not Vs divided by I. Similarly, the resistance R2 is Vs divided by I2. So we cannot calculate R2 as Vs over I. Thus the current that we use in this formula must be current flowing through the resistor, not just an arbitrary current in the circuit. If you liked this formula video and you learned something today, please subscribe to my YouTube channel, follow my LinkedIn page, like my Facebook page, or follow me on the Twitter. Or you can visit my website eeSasha.com. I am constantly developing new courses that go in much more depth in all of these topics. Thank you and see you soon!